Welcome back to the deep dive. You know how we operate here. We get our hands on the densest, most critical documents. The ones that often sit behind clearance levels or require a pretty deep technical background to even start with.
And our job is to strip away that noise.
Exactly. To give you the actionable knowledge, the stuff you actually need to understand how the landscape around us is, well, fundamentally changing.
And today, the document we're looking at it's nothing short of a blueprint for global continuity.
Yeah, that's not an exaggeration. We are working directly from a 2025 confidential white paper from a company called T.L TEDFORD Technologies, or TLTE.
And this was prepared for some very serious players. We're talking the U.S. Department of Defense, Homeland Security, even allied governments.
And the key thing to grasp is that this isn't just proposing an infrastructure upgrade. It's proposing a foundational structural safeguard for, well, civilization itself.
They really is.
Okay, so let's unpack this. Our mission for this deep dive is to go deep into this TLTE vision for what they call a Layer 0 Earth-anchored network. It's a hugely ambitious concept.
Massive.
So we need to assess, really, three things. First, the necessity. Is it really that urgent? Why do we need this massive change right now? Second, its revolutionary nature. I mean, how does it actually work? What makes it so different?
And third, the big one, is it even doable? The plausibility of it all.
Right. This whole dive is about understanding this planned, really dramatic transition from a world that is totally reliant on orbit.
The one that's built on terrestrial resilience. And that transition is what makes this paper just so compelling.
It reframes our entire reliance on space assets. It's not a convenience anymore.
No, it's an existential vulnerability.
Absolutely. And to really grasp the stakes here, you have to internalize this core concept that just drives the entire project. They call it orbital fragility.
A very deliberate term.
Right. As you're listening to this, as you're navigating your world, your finances are being synchronized. All of it depends on a system we just completely take for granted.
Thousands of satellites.
Thousands of them orbiting high above us. And they're not just for, streaming video. They provide the world's timing, its location, its communications backbone, what we call PNT.
Position, navigation, and timing.
And the source material is, it's brutally honest about this.
It really is. It states very clearly that this dependence has created a single point of catastrophic failure. What happens if those 9,000-plus active satellites just fail?
And we're not talking about a little service outage.
No, we were talking about catastrophic failure modes. Things triggered by, say, space debris, a severe solar storm, or, and this is the crucial part, a deliberate attack by a hostile actor, kinetic or electronic.
And that gets us to the core promise of the TLTE system. The entire reason they're pitching this to the highest levels of government. It's national continuity under any condition.
Any and all conditions.
So if we can actually build this Layer 0, it means that national operations, defense, emergency services, they all keep functioning, even if the sky goes completely silent.
And that, right there, is why this document is a complete game changer.
Okay, so let's start with that strategic context. TLTE lays out a picture that is pretty dire, but you have to understand it to feel the urgency of their proposal.
Right. They start by detailing the sheer, staggering scale of our current fragility. Today, basically everything.
Everything.
From the synchronization of global stock markets to the smart energy grids to automated transport systems, it all relies on those orbital assets and these big centralized cloud systems.
It's the number that's deceptive, isn't it? Over 9,000 active satellites. That sounds robust. It gives you this false sense of security.
It does. But the paper points out that this large geographically distributed network is, paradoxically, an enormous single point of failure.
Because the principle is centralized.
Exactly. They are all linked to centralized ground stations. They all rely on the same physical and electromagnetic domain to operate. So if you disrupt that domain...
You can disrupt everything at once.
And this reliance, it exposes them to a really multifaceted threat profile. We all think of kinetic threats, missiles.
Just blowing them up.
Yeah, but the source emphasizes that these systems are acutely susceptible to non-physical attacks. Cyber intrusions, sophisticated signal jamming.
And spoofing. That's the one that really gets me.
GPS spoofing, the injection of corrupt data. If you can spoof the PNT data of a container ship, you can grind global logistics to a halt.
Or a power grid. If you spoof the timing data for a power grid, you don't just cause an outage.
You create systemic instability, chaos.
And this all feeds directly into what I think is the most terrifying scenario they detail in the white paper. the risk of a cascading failure.
Hmm.
They warn that a large-scale orbital disruption, let's say a kinetic anti-satellite test, that creates this dense, fast-moving cloud of debris.
The Kessler syndrome.
Basically, yeah. That event could instantly trigger failures across every critical national sector.
You have to visualize it. Transportation systems, air traffic control, railways, maritime logistics. They all need synchronized PNT data.
Gone. Instantly. It would cause massive stoppages, probably accidents.
Then defense communications are blinded. You can't acquire targets, you can't coordinate units. Global finance, which depends on precise millisecond timing, it just seizes up.
And then there's the civilian side, emergency infrastructure, hospitals, fire, police. They lose coordination, they lose location services.
The white paper doesn't just call this a crisis. The term they use is systemic national shutdown.
And we have to talk about the even deeper layer of threat here, cyber and electromagnetic.
Right. The paper specifically calls out hostile actors exploiting weaknesses in the radio spectrum. Jamming is one thing. That's just crude signal interference.
But spoofing is the insidious part, isn't it?
It is. Broadcasting false PNT data to deceive receiving systems, making them think they're in the wrong place or even at the wrong time. It's a weapon of mass confusion.
And then there's the existential threat, the electromagnetic pulse, or EMP.
The big one, an EMP burst, whether it's from a high-altitude nuclear detonation or a, highly sophisticated conventional weapon. It unleashes this wave of high energy that can just fry unshielded electronics over a massive area.
And our current centralized cloud infrastructure, if that's not fully hardened, it could be taken down entirely.
And if that happens, and our systems are unshielded, we lose vast computational and communications capacity all at once, simultaneously.
This is the absolute crux of the problem, what TLTE calls the dependency crisis. As of today, despite billions and billions invested in upgrades, the global system lacks a functionally resilient terrestrial fallback.
There's no plan B.
No plan B. If those orbital links degrade, if the 9,000 satellites go dark or start spitting out corrupted data, we do not have an autonomous national-scale system ready to take over to maintain that PNT data flow.
It's a foundational vulnerability of the current paradigm that relies on satellites as the single source of truth for PNT.
And if you can corrupt or remove that source of truth,
the national machine just stops working. And that gap, that complete lack of terrestrial resilience, that is the necessity that Layer 0 is designed to fill.
So, okay, the problem is orbital fragility and terrestrial dependency. So the TLTE solution has to be revolutionary because it tackles that dependency head-on.
By anchoring the entire operational domain to the ground.
Right. So let's look at their mission statement. This is really the executive summary of the whole document. What is the core vision for this new Earth-anchored architecture?
The core vision is all about creating a network that is inherently resilient against that orbital failure. TLTE is proposing a next-generation Earth-anchored communications and navigation network designed specifically to guarantee national continuity.
And I love the phrase they use, restoring a resilient living backbone for the 21st century.
It's powerful. And crucially, they stress it's not just a replacement for satellites. It is a necessary, redundant, self-healing foundation that can operate on its own or work synergistically with space assets when they're available.
And the mission scope is, it's massive, and they say non-negotiable. It has to sustain uninterrupted operations for civil, defense, and Space Force domains.
Which means air traffic control, missile command, and your local fire department must all remain fully functional.
Even if the satellites and the central cloud servers are completely compromised.
Exactly. And the long-term ambition, this is really where you see the scale of it, is in their 2050 vision hook.
Right.
By 2050, the Tedford network is designed to move beyond just being a defense asset. It becomes the fundamental structural safeguard layer 0 of the global communications lattice.
And they define that layer 0 as an AI-synchronized, ethically governed, frequency-secure system.
And its purpose is ensuring humanity's continued connectivity and, this is important, its operational sovereignty. It elevates connectivity from just a service you pay for
to a governed structural requirement for societal survival.
So the necessity, I think we can agree, is clear. But the vision, it sounds colossal. That sounds almost too big.
It does. So for us to judge the feasibility, we have to look at the very specific mission objectives they set out. They list 5 critical goals, and these really highlight the ambition here, integrating high-level defense needs with everyday civilian utility.
And the first 2 objectives are they're tightly linked to immediate national security. Number 1, Continuity of government and defense operations.
The bedrock. This is the guarantee of command and control, C2, and situational awareness, even during a total orbital failure or a severe cyber attack.
The military cannot afford a blackout in the chain of command. Not for a second. Ever.
And then the second objective brings layer 0 right back down to the civilian level, resilient civil infrastructure.
Right. So this means maintaining emergency communications, ensuring transport coordination.
Or traffic lights, self-driving trucks, trains, all of it.
All of it. And, crucially, maintaining energy synchronization. PNT data is this hidden key that keeps the power grid stable and running smoothly. Without it, you get blackouts.
So then the third objective, this is what sounds like the implementation nightmare.
It is. But it's also a revolutionary goal if they can pull it off. Interoperability.
So the new architecture has to integrate seamlessly and securely with all the existing network standards.
Across the board. DoD, DHS, FAA, even NATO allied networks. This isn't just, bolting on a new system. It requires making this new foundation communicate flawlessly with the aging, fragmented architecture that's currently running the country.
Which immediately raises a huge question about technical debt, about bureaucracy. I mean, if some of our defense systems are already decades old, is seamless integration even realistic?
That is precisely the challenge. And the white paper, it addresses this by committing to an open architecture standard, which we can get into in a bit. But to your point, this objective forces that integration to happen from the ground up, instead of trying to retrofit it later on.
Okay, that makes sense.
But it's the fourth objective that introduces the true paradigm shift: ethical AI governance.
For me, this is the revolutionary part. They plan to embed lawful autonomy and the do no harm principle at the core of every single node.
It's not an afterthought. It's a proactive, ethical mandate right from the start.
It feels entirely unique for a project this size.
It is. It reflects this reality that for a self-healing autonomous network to be trusted by both civilian populations and military command structures, its decision-making framework has to be predictable, transparent, and ethically constrained. The network's intelligence have a moral baseline baked right in.
And then finally, the fifth objective outlines the financial path, the scalable transition path.
Right. This mandates a migration framework, moving from that initial, highly secured defense deployment and validation
to mass civilian commercialization, which they say will be funded primarily through massive venture capital expansion.
And this dual-use pathway is how they propose to achieve continental scale and do it quickly and, relatively speaking, affordably.
So achieving all 5 of those objectives at the same time, that's what defines Layer 0 as revolutionary.
It is. They're solving a military resilience problem using a technology that's designed for mass market economic scaling, and the whole thing is governed by mandated ethical constraints. It's a new way of thinking about infrastructure.
Okay, so now let's get into the unpacking of technology influence. TLTE identifies 4 specific global challenges and then offers these disruptive technological responses that just fundamentally break with the current system.
And let's look at those challenge response pairs, because this is really the nuts and bolts of the innovation.
Okay, first one, the most critical one, challenge, orbital dependence. The response they offer is autonomous terrestrial mesh PNT.
Right, so traditional PNT relies on the clock synchronization of satellites way up in orbit, which, by the way, requires constant correction for relativistic effects.
A whole other deep dive.
A whole other deep dive, yeah. But the terrestrial mesh PNT, it flips that on its head. It creates an extremely dense lattice of ground nodes that use ultra-stable local clocks and proximity ranging to self-synchronize.
So they provide highly accurate timing and location data locally without needing to look up at the sky.
Exactly. The strategic impact is absolute PNT integrity. If GPS goes dark, the network switches seamlessly, instantly, to the GMN's local verified data source.
Which guarantees defense coordination and civil safety.
Instantly.
Okay, second challenge. This one relates directly to the speed and survivability of the network. Challenge, latency and vulnerability. And the response is edge autonomous AI processing.
This is a huge shift away from centralized cloud computing.
Yeah.
In traditional networks, your data has to travel sometimes hundreds of miles to a remote data center to be processed.
Right.
In the TLTE system, the intelligence, the AI, resides at the network edge. It's right there inside the thousands of ground nodes.
So you get millisecond reaction times, which is non-negotiable for like an anti-collision protocol.
Non-negotiable. But the other strategic benefit is EMP resilience. A centralized data center is a single, large, juicy target.
But if you distribute the processing across millions of nodes,
no single EMP burst can take the entire system down. It's the computational equivalent of decentralization, protecting against attack.
Okay, the third challenge speaks to that pain point we talked about, the bureaucratic networks. Challenge: fragmented standards. The response: open architecture, 6G GPS 3 interfaces.
This one directly tackles that interoperability headache. TLTE isn't creating some proprietary walled garden here.
Which is what you'd almost expect.
You would.
Hmm.
But by designing the system to interface natively with the latest international standards, specifically future 6G networks, and the secure GPS 3 signals used by the military, they ensure seamless cross-agency and allied interoperability from day one.
So they're aiming to unify all these disparate government and defense communication systems under one reliable, highly secure PNT backbone.
That's the goal.
All right, and finally, the challenge that requires the most advanced technological and philosophical response. Challenge: human-machine disconnect. The solution is the Spiral AI Synchronization Core, or SETS.
The SASE is more than just software. It's a governance structure. Its strategic impact is guaranteeing human command, clarity, and ethical control over what is, by its very design, an autonomous network.
So it makes sure the speed and the rapid self-correction of the AI don't lead to mission creep or, ethical violations.
Exactly. It's the core mechanism that enforces that do no harm principle and maintains operational sovereignty with human-in-the-loop oversight.
It really sounds like the technology, the architecture itself, is designed to enforce the ethical objectives. That feels truly novel in a system of this scale.
So now we get into the physical design. If the technology influences the what, the system architecture is the how. And this is really where we gauge the plausible reality of layer 0.
Okay, so the structural foundation of the entire system, its nervous system, is the ground mesh network, GMN. The paper describes it as this vast distributed lattice of intelligent nodes. How many are we talking about, and how does this physical arrangement actually make it self-healing?
We're talking about potentially millions of low-power terrestrial transceivers. And you're right, we're not talking about massive cell towers. These are small, hardened nodes.
Oh.
They're arranged in overlapping hexagonal cells across large regions, and each node operates as a miniature autonomous router, transmitter, and receiver.
And the self-healing capability is the core innovation here.
It is. In a standard network, if a link fails, data transmission just stops. With the GMN, if a node is compromised or jammed or even physically destroyed, the surrounding nodes immediately detect that signal loss.
So instead of trying to route data back to some central server that might be offline, what does the GMN do?
It leverages proximity and a concept called signal coherence. Data packets are rerouted almost instantly, we're talking microseconds, to the nearest operational neighboring nodes.
So the network doesn't wait for a human to intervene.
No. The system recalculates the optimal path based on local signal strength and integrity. This continuous automatic rerouting, all powered by that edge AI, is what guarantees resilience.
And the paper says coverage scales from a regional, say, 50-mile radius initially.
All the way to continental via this process of node chaining and frequency hopping. It makes the entire continent functionally robust.
So it's a massive physical grid, and it's designed to mimic the resilience of a nervous system. If one nerve path is cut, the signal just finds an adjacent path immediately.
That's a perfect analogy. And on top of the GMN backbone, they've developed these dedicated components for specific safety needs. The Tedford Vehicle Alert System, or TVA, is one of the most critical.
And this is purely for transportation safety.
Purely.
What failure mode is the TVA specifically designed to prevent?
It directly addresses the dangers of relying solely on GNSS, like GPS and ADS-B.
Which is the system for aircraft location.
Automatic dependent surveillance broadcasts, yeah.
Yeah.
If a hostile actor successfully spoofs GPS signals to, say, ground an entire airline fleet, or if bad weather degrades ADS-B signals, the TVA provides an immediate, independent, highly accurate PNT safety net.
And how does that function in real time?
The TVA nodes are constantly exchanging this highly secure PNT data. It uses predictive AI modeling to project the trajectories of objects, aircraft, ships, autonomous ground vehicles, and it broadcasts avoidance commands or validated location data.
So it's the ultimate self-contained anti-collision protocol.
That's what it is. It's an insurance policy written in hardened firmware, effectively guaranteeing that the world's transportation systems stay safe even when the primary orbital navigation systems fail.
And then tying all of this autonomous physical infrastructure together is the brain, the Spiral AI Synchronization Core, SSC. How decentralized can this living brain really be if it's governing millions of nodes?
That's a great question. SASE is decentralized in its processing and its presence, but it's centralized in its governance model.
Okay.
It's the master system that governs lawful AI behavior. It manages the incredibly complex frequency allocation across the entire mesh to prevent interference, and it handles the consensus validation that roots out bad data.
So while the processing happens at the edge,
SASE ensures all those millions of autonomous decisions align with the do no harm principle and the defense ethical AI directives. It's basically the constitutional framework for the network's existence.
that makes sense. Okay, we've covered the what and the why. To really solidify the doability, let's look at the operational reality through their breakdown of the 4 functional layers. This is the blueprint for how it gets built and run.
Right. Layer 1 is physical infrastructure. This is the tangible, ruggedized component. The source specifies that nodes have to be installed along transport corridors, power lines, and defense installations. And the critical compliance requirement here is MIL STD 810H.
Now, for you listening who might not be familiar with defense standards, what does MIL STD 810H compliance actually mean for Layer 1?
It means these nodes have to be engineered to survive the absolute worst environments you can imagine. We're talking extreme temperature fluctuations, deep-sea submersion, constant vibration, shock, dust, chemical contamination.
And crucially, protection against electromagnetic interference and radiation.
Exactly. These nodes aren't delicate computer servers in an air-conditioned room. They are hardened, tamper-detected, shielded bunkers designed to function even after a major disaster or attack. They are the literal, physical definition of resilience.
Okay, then we move up the stack to the functional layer. Layer 2, signal processing and routing.
This is the dynamic engine of Layer 0. It relies on a hybrid system using both RF, radio frequency, and high-capacity optical switching. The key here is adaptive load balancing.
So the system is constantly monitoring traffic and resource availability.
Constantly, and optimizing data paths in milliseconds. It's not just following a preset fiber path. The network dynamically chooses the best path through the mesh based on real-time signal coherence, which makes it extremely efficient and almost impossible to bottleneck.
All right, layer 3 is command and control. This is the security and accountability layer, and it's where that human-in-the-loop requirement gets enforced.
Layer 3 is all about maintaining the authenticity of every single transmission. It uses what they call human-verified AI consensus.
So in simple terms,
The AI autonomously executes vital functions. But if a transmission involves a critical change in operational state like rerouting defense communications or issuing a specific alert command, multiple AI decision pathways have to agree.
and the final action is subject to a human authorization loop.
Yes. This design, which is mandated by DoD Directive 3000.09 compliance, specifically removes the possibility of a spoofed hostile command being executed autonomously. The human operator is the ultimate veto power over Layer 0's intelligence.
It's a distributed system, but with centralized, required human accountability. That's a really careful balance. And finally, layer 4 is the user interface.
Layer 4 is the gateway. This is where secure API gateways are established to allow agencies like the FAA or FEMA and industry partners to integrate seamlessly. It ensures that while civilian and defense sectors can access the robust PNT and communication services,
They do so without compromising the integrity of Layer 0's core infrastructure. It's the secure front door that connects the foundation to all the applications that will run on top of it. A network this ambitious, spanning continents and demanding military-grade resilience, well, it requires a highly structured, aggressive timeline. The white paper lays out a massive 25-year plan, spanning from 2025 all the way to 2050.
and this phased deployment is crucial to assessing its doability.
For sure. The initial phases are all designed for high-risk validation, leveraging existing defense budgets and infrastructure. Phase I, from 2025 to 2026, that's the prototype stage.
Right. Initial mesh deployment focused on high-priority infrastructure. Think FAA, air traffic control corridors, and critical USAF bases. The validation here has to come from an unimpeachable source.
Hence the role of Lockheed Martin as the prime contractor for the initial certification.
Exactly. They have to prove the technology meets defense standards right out of the gate.
Why Lockheed Martin specifically? What do they bring to the table?
Well, Lockheed Martin already manages massive, complex systems. They're central to the GPS-3 satellite development and large portions of DoD command and control. Their certification provides the immediate credibility that government agencies need to trust this unproven Layer 0 architecture. They're a known quantity.
Okay, that makes sense. So moving into phase 2, 2027 to 2028, we see the focus shift to integration and safety.
Yeah, this involves the full integration of the TVA system we talked about. securing FAA certification for it, and then the crucial interagency interoperability testing with DHS and the DoD.
So this phase is all about proving the system can move beyond the prototype and talk flawlessly to the entire existing federal ecosystem.
Precisely. And then comes the make or break phase. Phase 3, from 2029 to 2032, homeland trials.
This is where the National Pilot Program kicks off under two crucial frameworks, COPE and JADC2.
Right. And we should dedicate some time to explain what those two acronyms mean, because they are the ultimate stress test for Layer 0.
Let's start with COPE.
COOP stands for Continuity of Operations Plan. It's the critical, established framework used by the U.S. government to ensure essential functions continue during a major disruption.
Like a natural disaster or a national security crisis.
Exactly. So testing under COOP means TLTE has to prove that Layer 0 can sustain government operations when traditional infrastructure has completely failed. The ultimate goal of Phase 3 is establishing an EMP-resilient field network that can maintain continuity when every other system goes dark.
And JDC2, that's the Joint All-Domain Command and Control.
Yeah, JDC2 is the DoD's big vision, their framework for connecting all military sensors and shooters across land, sea, air, space, and cyber into a single, unified information grid.
So integrating Layer 0 into JEDC2 means proving that this terrestrial mesh can serve as the reliable, low-latency, resilient PNT and C2 backbone for future multi-domain warfare.
That's it. If Layer 0 can satisfy JEDC2 requirements, it's validated as the national standard for resilient communications.
Okay, so once that crucial homeland validation is complete, the blueprint calls for massive expansion.
Exactly. Phase V, from 2036 to 2040, is the hinge point, civilian commercial expansion. This is when the venture capital consortium steps in.
To fund the mass rollout of the GLC-NM, the Global Living Communications Network, MESH.
And that marks the transition from a specialized secure defense asset to a foundational civil utility.
And the ultimate goal is Phase 6, 2041 to 2050, global integration and autonomous maintenance.
Which is achieving a planetary-scale mesh with self-governing AI, establishing Layer 0 as the global infrastructure standard.
This phased approach, it's really clever. It allows the U.S. government to validate the security and resilience in phases I through 3.
And then offload the massive capital expenditure needed for global scaling onto private venture capital in Phase V.
Let's connect this timeline to real-world applications, the strategic integration across sectors. For defense and space operations, this goes beyond just being a backup system.
Oh, it's about operational dominance. It provides continuous command and control links even during orbital degradation, ensuring a seamless connection between Space Force ground commands and their orbital assets. It directly enables that multi-domain coordination that JEDC2 requires.
Making every platform a node in a resilient communication grid.
Exactly.
Okay, for Homeland Security, what's the immediate functional benefit?
It creates a nationwide alert grid that is capable of operating when the power grid is down. Think of FEMA and first responders during a massive blackout or a large-scale disaster. Layer 0 guarantees their communication, their location tracking, their synchronization.
So it's the guaranteed lifeline during chaos.
That's the idea. It integrates seamlessly with legacy emergency broadcast systems to make sure the message gets out.
And for civil infrastructure, how does Layer 0 actually affect your daily life?
It provides the foundational synchronization stability that's necessary for pretty much all next-generation technology. It supports smart city integration, it ensures energy grids are perfectly timed to prevent failures, and it makes transport logistics, especially autonomous vehicle coordination, far, far safer with real-time telemetry.
So it basically removes the PNT uncertainty that's currently holding back a lot of these ambitious smart infrastructure projects.
It removes that single point of failure.
This level of integration brings us to the crucial discussion of economic and industrial synergy. A project this huge has to be economically plausible.
And the economic logic is all based on that dual-use strategy and the de-risking that's provided by the government validation. The paper details key partnerships.
Lockheed Martin and the USAF provide the initial engineering credibility.
Right. And then you have partners like Raytheon L3 Harris, handling the specialized node manufacturing and secure spectrum equipment. But the true scaling
Relies on domestic telecom alliances coordinating the civilian rollout.
It does. The economic synergy is really powerful here. Government investment in the early phases proves the technological resilience in the most demanding environment possible.
And that trust then unlocks private capital for mass production and commercialization in Phase V.
The projected market impact is staggering. It reflects the foundation-level necessity of the service.
Hmm.
They project a combined defense and civil infrastructure market value of over $220 billion by 2040.
And the defense contracts provide a robust, reliable revenue floor.
They do. It grows from a $3.5 billion baseline in 2025 to $22 billion by 2040.
But the real growth engine here is the civilian deployment.
Absolutely. The civilian deployment, driven by the need for guaranteed PNT in logistics, energy, smart cities. That's expected to hit $38 billion in annual revenue by 2040.
And this entire enterprise becomes a massive job creator.
Huge. The projection calls for growth from about 7,000 highly specialized jobs in 2025 to over 500,000 skilled jobs in engineering, cyber operations, and maintenance by 2040.
So it's not just a government project, it's the creation of an entirely new foundational industrial sector.
That's how they see it. And for the venture capital partners who are funding that civilian expansion, the projected return on investment is very attractive. They're looking at 3 to 5 times their investment within 5 years of market entry.
And that kind of ROI is only possible because the U.S. government has already spent billions proving the technology works flawlessly under threat. The risk has been removed for them.
So we've established the necessity and the plausibility, but the adoption, especially by civil agencies and our allies, that hinges entirely on trust.
Right, which brings us to the structure safeguarding the whole system: ethical governance and security.
And given the sheer autonomy of millions of nodes, the enforcement of core ethical principles is paramount.
They state the CSC must encode the do no harm principle into its firmware. What specific concepts does that principle enforce? It's more than just simple non-maleficence, right?
It is. It's codified through 3 specific mandates. Non-maleficence, which is do no harm, veracity, which is truthfulness, and proportionality.
Okay, so veracity means the network can't knowingly transmit false information.
Which directly counters the spoofing threat we talked about. And proportionality means that in any autonomous decision, the CSC has to weigh the potential benefits against the potential risks, ensuring the network's actions are always aligned with the lowest level of necessary force or disruption.
And these are not soft rules.
No, these are enforced algorithmic constraints.
Let's discuss the multi-layered security framework that protects the system from physical and cyber attack. We already touched on the physical hardening of the Layer 1 nodes with MIL STD810H.
Right. And on the network security side, they rely on 2 critical modern paradigms. First is Zero Trust Architecture, or ZTA.
ZTA is a huge buzzword in cybersecurity right now. For you listening, what does that mean in practice for Layer 0?
ZTA means that absolutely no user, no device, and no internal network segment is inherently trusted, regardless of its location. Every single access attempt, even between 2 internal GMN nodes, must be verified and authenticated.
Which radically minimizes the attack surface.
Radically. And coupled with ZTA is mandatory multi-key encryption and the use of rotating spectrum allocation, aligned with very stringent DoD requirements. It makes the network far harder for hostile actors to predictably exploit or jam.
The section on AI consensus seems key to data integrity. How does this distributed validation mechanism of the GMN prevent someone from injecting false information?
Well, because the network is so dense, any transmission is immediately validated by multiple surrounding nodes. If a single node tries to broadcast corrupt PNT data, the system's consensus mechanism, which is run by the CSC at the core, requires cryptographic truth tokens signed by 3 independent verifiers before it will accept that data.
So this distributed validation effectively eliminates single-point spoofing attacks.
It does. It makes the data highly trustworthy, which is absolutely essential for defense and civil safety operations.
And crucially, they enforce the operational oversight requirement. The human-in-the-loop review, compliant with DoD Directive 3000.09. Can you give us a concrete example of when that human authorization loop would actually kick in?
Sure. Imagine the network detects an immediate critical threat, like an incoming missile trajectory or a massive impending grid failure. The AI autonomously calculates a necessary counteraction, let's say shutting down a specific frequency band or issuing an immediate redirection command to an autonomous military asset.
Okay.
Before that command executes, the AI has to present its rationale to a human operator within a specified time window, and it requires human authorization for the execution of that specific countermeasure.
So it ensures the speed of autonomy doesn't bypass human strategic control, especially in a conflict scenario.
That human authorization loop is the ultimate check against runaway autonomy.
Finally, we have to address data integrity and privacy, especially when we talk about the civilian sector. If this network is going to be layer 0 for everything, how do they guarantee privacy during that Phase V rollout?
They recognize that civilian adoption relies entirely on trust. So the white paper makes two ironclad guarantees.
Yeah.
First, data integrity. Every transmission is signed by a cryptographic truth token and confirmed by verifiers.
And second, and this is critical for privacy.
Civilian data is protected by zero-knowledge encryption, with a specific guarantee of no commercial data harvesting.
Can you elaborate on zero-knowledge encryption for our listeners? Why is that the privacy silver bullet here?
Zero-knowledge encryption is revolutionary because it allows the network to verify a piece of information without ever learning the content of that information.
Okay, give me an example.
For instance, the network can confirm that a civilian vehicle is operating within designated safety parameters and that its telemetry is authentic, which is necessary for the TVA system, without ever accessing the vehicle's specific journey history or any personal usage data.
So it guarantees the integrity of the input while maintaining the privacy of the content.
And that is the mechanism that ensures public trust when Layer 0 becomes a global utility.
As we look past the initial 25-year deployment, we move into the 2050 vision, the living network era. Now, this sounds less like infrastructure and more like science fiction.
The definition is ambitious. The Tedford network transitions into a planetary nervous system, a symbiotic relationship between human, machine, and the environment.
So unlike static passive infrastructure,
The living network is designed to sense and adapt to environmental changes, threats, resource availability. It self-corrects continuously under stress. Its operational goal is to achieve near-perpetual resilience.
what are the necessary future-proofing characteristics that are required to make this vision a reality?
It focuses entirely on extreme longevity and autonomy.
Right.
We're talking self-healing nodes that maintain 99.99% uptime, relying entirely on renewable micropower sources for sustainability.
And crucially, future-proofing against quantum computing threats.
Exactly. This means the system has to migrate to post-quantum encryption, specifically lattice-based cryptography after 2035. That's before quantum computers become powerful enough to threaten current encryption standards.
And that shift is already budgeted and scheduled in the appendices.
It is. They're planning for it now.
Speaking of the future, Appendix D outlines the next frontier of R&D. These are the projects that signal that Layer 0 is just the beginning.
Yes. The focus is on expanding the ethical and physical boundaries of the system. They are actively developing AI moral reasoning engines for autonomous conflict resolution,
So moving beyond just following rules.
to active ethical decision-making in complex environments. This is a crucial step towards that 2050 symbiotic model.
And physically, the mesh has to get smaller, but also stretch further.
Precisely. We see nanomesh expansion for deployment in dense urban environments where traditional nodes are just too large. These micronode arrays would allow Layer 0 connectivity in hyper-congested cities.
And the most futuristic goal.
Deep space relay bridges. This involves extending the Tedford architecture off-world, providing autonomous, reliable PNT and communication support for future lunar and Martian missions.
So Layer 0 is designed to anchor humanity on Earth, but also structurally support its expansion into the solar system. This has been an absolutely comprehensive deep dive into the blueprint for Layer 0. I mean, if we synthesize this massive vision, the TLTE system is presented as the next great human infrastructure project.
It really is.
It's a permanent structural safeguard, engineered against the fragility of our orbital environment, the threat of EMP, and sophisticated cyber warfare. It's a unified infrastructure suite built for defense continuity, global civil resilience, and even deep space applications all at the same time.
The necessity and the technological blueprint are clear. Layer 0 is an Earth-anchored solution to a sky-high problem. It provides a verifiable, secure foundation that stabilizes every other high-tech system that relies on precise time and location data.
And here's where it gets really interesting for me and where we want to leave the final provocative thought with you, the listener. The entire success of this planetary nervous system, it rests on one single thing. The effective, verifiable enforcement of ethics. We're not just trusting physical redundancy here, we are trusting codified morality.
That's a great way to put it.
We are talking about embedding do no harm, veracity, and proportionality into the firmware of millions of autonomous terrestrial nodes, all managed by the SASC.
And that raises a profound question. As that 2050 vision implies greater autonomous governance, and as those AI moral reasoning engines develop, how does the balance of power shift?
Exactly.
When the foundation of your continuity and security, your literal navigation system, is governed by an enforceable, ethical AI core, how do you truly define operational sovereignty? And what does it mean for human trust when the planet's life support system is built not just on physics and engineering?
Well, on algorithms that are designed to be ethically incorruptible.
That's the ultimate question of the living network era.
Thank you for joining us for this deep dive into this absolutely critical strategic white paper. We hope you feel thoroughly informed about the necessity, the architecture, and the revolutionary potential of Layer Zero. We will see you on the next deep dive.